Hi, my name is Taylor, and today we're going to do this calculus problem. A fence must be built to enclose a rectangular area of 20,000 feet squared fencing material that costs $3 per foot for two sides facing north and south, which is our X, and $6 per foot for the other two sides, which is our Y. Find the cost of the least expensive fence. So our first step, we're going to need to find what equals C, our cost. So C equals 6x plus 12y. And here we're doubling the numbers for both sides of the fence. We also need to find our area equation, which is x times y equals a. Now, when we split the x and the y, we're going to start out with y equals 20,000 over x. Next, we need to take y out of c so we can find x. So c will equal 6x plus 240,000 over x. And we get this 240,000 from the 20,000 that it cost times 12, which is our y. Let's erase some of this. So c equals 6x plus 240,000 over x. Our next step is to find the derivative of c. So c equals 6 minus 240,000 over x squared. So we have our derivative. And now we need to solve for x. So 6 minus 240,000 over x squared equals 0. So let's take away the 6, negative 240,000 over x squared equals 6. Negative 6. And we're going to multiply this x squared on both sides, so this cancels out, and we're going to equal to negative 240,000 equals negative 6x squared. And we will take out negative 6, divide on both sides. So let's erase some of this. So we're here, and once we erase the x squared, we're left with x. Once we erase the 6, we're left with x squared equals 40,000. And once you square root the 2, x now equals 200. And x also equals negative 200. So now we've got to use the second derivative test, which states that f to the second derivative, when it's greater than 0, it has a local maximum. When it's less than 0, it has a local minimum. And when the derivative is 0, the test gives no information. So we got to find the second derivative to c now to figure out which number works. So the second derivative of c is, the first derivative of c is 6 minus 240,000 over x squared. So when we take the derivative the second time, we're going to take that 6 out, and we're going to have 480,000 over x cubed. Now we need to evaluate the second derivative of c at 200. So when you plug in 200 for x, the second derivative of c in your calculator should equal 3 over 50. Now 3 over 50 is greater than 0, so x is a local minimum at 200. So we're going to now use the critical point theorem to show that the function of c has an absolute minimum at x equals 200. The critical point theorem supposes that a function f is continuous on an interval 1 and that f has exactly one critical number on the interval. If f has a local minimum, which is 200, x equals c is the absolute minimum of f in the interval of 1. Since c has a local minimum of x equals 200, then this local minimum is the absolute minimum of c on an interval of 0 to infinity. So we have our value of x, now we need to find y. Our equation for y is 20,000, which is the cost, divided by x, which is also 200. So 20,000 divided by 200 equals 100. So our y equals 100 and our x equals 200. So we have our x and our y. We just need to determine the cost of the least expensive fence with our original equation, which is 6x plus 12y. So 6 times 200 plus 12 times 100 equals 2,400. So the cost of our least expensive fence is going to be $2,400. I hope you learned something today, and thank you for your time.